Hello dear students, welcome to Konar classes. In this session, we are going to discuss the solution to 3 questions on differential equations in which we need to apply the concepts of variables separation. Out of these 3 questions, the first 2 questions we will see that how to represent say family of curves by given by differential equation, and the third question we are going to work on a practical problem. Okay, these questions are fundamentals, basics, but understanding the solution to these questions will help you to give enough confidence to solve relatively complex problems. Okay, so let's start one by one. The first question I am writing from my notebook, dear students. The first question is, find the equation of the curve. Find the equation of the curve. Equation of the curve passing through the point 1, 1, passing through the point 1, 1, whose differential equation is, I am writing in short as DE, differential equation is x dy is equal to 2x square plus 1 dx, and it is given that x is not equal to 0 for obvious reason, right? Now dear students, how to approach to solve this equation? This is the differential equation, okay, and let's see what we can do out of this question. So from this, what we can write, that we can write this implies dy is equal to 2x square plus 1 by x, 2x square plus 1 by x dx, correct? As it is given x is not equal to 0, so we can divide by x, correct? This implies dy is equal to 2x dx plus dx by x. Now what we are going to do, dear students, we are going to perform integration, and 2 is a constant, so we took outside of the integration and this one, correct? So if we perform this integration, so from here what we get y is equal to 2 into x square by 2 plus integration dx by x, that is log of mod x, plus c, where c is integrating constant, right? So from here what we can write, so if we simplify, we are going to get y is equal to x square plus log mod x plus c. Now dear students, this is the general solution of this differential equation. This is the differential equation and this is the general solution. And this is a general solution means in one way we can say this is a family of curves, okay? And if you look into the question, find the equation of the curve passing through the point 1, 1. The moment this family of curve, family of curve means there are many curves. Out of those curves, one is passing through the point 1, 1. Then the moment we apply the value of x equal to 1 on y equal to 1, because it is passing through 1, 1, then we can find the value of this arbitrary constant, and then we get the particular solution of the differential equation. That means a specific curve. How to get it? So here we write that at x equal to 1, y is equal to 1. Why? Because it is passing through the point 1, 1. So from here, if we apply this thing, what we are going to get? Y is equal to 1, that is equal to x equal to 1, that means 1 square plus log of mod 1 means 1 plus c. This implies 1 is equal to 1, log 1 we know 0 plus c. So from here we get the value of c is equal to 0. That means the value of this arbitrary constant becomes 0 when x equal to 1 and y equal to 1. Then dear students, from these equations, that is the general solution or the family of curves, the way you can say. So this now become y equal to x square plus log of mod x. This is the required answer to the given question. Find the equation of the curve. So this is the equation of the curve. Okay, passing through the point 1 comma 1. It is passing through the point 1 comma 1. Okay, if you apply x equal to 1, you will get y equal to 1. Whose differential equation is this? So first we solve this differential equation using variable separation method. Okay, and then apply the specific value of x and y to find the particular solution. Okay, so now let's proceed to the next question, dear students. Okay, you also write the questions the way I'm reading and writing the question. You also write it down. Okay, I do not use any digital board for very fundamental reason. This is the traditional way of learning, and that has not changed. Okay, because unless you write by your own and both the questions and answers, it really cannot get inside you. That is my belief. Okay. The second question is that find the equation of a curve. Find the equation of a curve passing through the point the coordinates of the point is minus 2 comma 3, given that the slope of the tangent to the curve, given that the slope of the tangent to the curve at any point xy, tangent to the curve at any point xy, any point x comma y is 2x by y square. Okay. Let us first understand what is actually meant by the slope of a curve. If you recall, when we discussed the applications of derivatives, there we understood one point. If there is a curve y equal to fx, then at any arbitrary point x comma y, what is the slope of that curve? That means if you draw a tangent at that particular to the curve, what the angle that tangent is making with the positive direction of x-axis, that is denoted by dy dx. Whatever I said, I can write something like this. So let's look at this. Okay, if these are the coordinate axis, okay, this is x dash, y dash, and this is origin. So what is the curve? Suppose the curve is something like this. Okay, so this is the curve. Suppose this curve is y equal to fx. Now if you take any point on this curve, okay, and if we draw a tangent, suppose we draw a tangent something like this. Let me draw the tangent properly. Okay, now this is the tangent. Okay, now if this particular point, if the coordinate of that point, suppose if it is P having coordinates x comma y, and if this is the angle theta, then what is slope we know? M, right? Remember tan theta. And this tan theta is nothing but dy dx. According to the question, what is given, dear students, that dy dx equal to 2x by y square. So dy dx is equal to 2x by y square. So we need to solve this differential equation. From their variable separation method, y square dy is equal to 2x dx. Then we can integrate both the sides. 2 is a constant, so we can take outside of the integration. So integration y square dx, y square dy, it is y to the power 3 by 3, that is equal to 2 into x square by 2 plus an integrating constant, suppose c. Okay, so from here what we get, dear students? So from here we get that y cube is equal to 3x square plus 3 into c. 3 into c, we can make it another arbitrary constant c1. So you can write where c1 is equal to 3 into c. Okay. So by the way, this is the general solution to the given differential equation. This. Okay. And this differential equation is interpreted from this statement, problem statement. Slope of the tangent to the curve at any point x comma y means dy dx, and that is equal to 2x by y square. Done. Now from this general solution, that means it is a family of curves. All these family of curves having a common thing. What is that? If you take any point x comma y, if you draw a tangent, and then tangent, okay, is making an angle theta with the x-axis, then you will find that value of tan theta will be 2x by y square, always it will be. Now from this family of curves, we need to find a specific curve which is passing through the point minus 2 comma 3. So for that, what we need to do, dear students? Here we need to apply the value of y equal to 3 and x equal to minus 2, correct? So we can write it here. So here it is y equal to 3 and x is equal to minus 2. If we apply, then what we are going to get? 3 power 3 is equal to 3 into minus 2 whole square is 4 plus c1, correct? Okay. So from here what we get, the value of c1 is equal to 27, 3 into 3 into 3, that is 27 minus 12. So from here we get the value of c1 is equal to 15. Now dear students, if we apply the value of c1 is equal to 15, we get a particular solution, that is the specific curve. So how to get it? So from here what we will do, we will apply the value of c1 equal to 15. c1 is equal to 15, and we get the curve as y cube equal to 3x square plus 15, or we can write, this implies y is equal to 3x square plus 15 power 1 by 3. This is the answer to the given question. Okay. Now dear students, the third one is a practical question, and that I am going to write first and followed by its solution. Okay. The third question, I am going to write it here. Okay, in a bank, the question is, in a bank, principal increases continuously at the rate of 5% per year. Okay, got it? Per year. In how many years? The question is that in how many years rupees 1000, okay, double itself. Okay, so let us first understand what is meant by this question. The first line is very important. All the lines are important, but from the first line we can actually interpret what is the differential equation. In a bank, principal increases. The principal, let's assume let the principal be P. Let the principal amount, okay, principal be P, okay, and it is increasing continuously at the rate of 5% per year. Increasing continuously with respect to what? With respect to time. Okay, so let's time be T. That means dp dt. What is meant by dp dt? It is a rate of change of P with respect to T. If you recall, T, what is T? Is time. Time is independent, right? Time is, there is an English saying that time and tide wait for no one. So time is not waiting. Time is actually independently going through. And as time goes by, the rate of change of P is dp dt. That is, the principal increases, means the principal is actually changing with respect to time, but it is increasing in this way continuously. In this, according to the given question, it is increasing continuously at the rate of 5% per year. That means what? That should be equal to 5 by 100 into P. Correct? So from this statement, what I was saying, dear students, from this statement we are able to give a mathematical statement something like this, which is a differential equation. dp dt is equal to 5 by 100 into P. Okay, so now we need to solve it. Why we need to solve it? Because the next question, next statement is giving the question. In how many years rupees 1000 double itself? Okay, so from here what we can write, dear students? So from here we write dp by P is equal to 5 by 100 means 1 by 20 into dt. Integrate both the sides. Correct? Integration dp by P, that is equal to, what is that? Log P to the base E is equal to 1 by 20 into T plus 1 integrating constant C. Correct? So from here what we can write, dear students? So from here we can write P is equal to e to the power, okay, T by 20 plus C. Correct? This is the general solution to the given differential equation. Okay, this is the differential equation, and for this differential equation we found this general solution. But our question is that we need to give an answer to a specific question. In how many years rupees 1000 double itself? Okay, for that, one thing is that we need to remove this arbitrary constant, means we need to find a specific value to this one. And how we can find this specific value? So let's come here and come to this part and discuss. Okay, one thing, dear students, is that you see that when the value of p is equal to 1000, then the time is what? 0, because that is the beginning, right? With the principle of 1000, I am going to find the time required to double itself. So when I invested that 1000, when I put that principal 1000 in the bank, that is the beginning of the time. That means t is equal to 0. Correct? That is a statement we can infer. So when t is equal to 0, that p is equal to 1000. We will apply here. So what we will get? 1000 is equal to e to the power 0 by 20, correct, plus c, correct or not? So 0 by 20 is 0, that means e to the power c become 1000. So from here we get e to the power c is equal to 1000. Now that value of e to the power c is equal to 1000 we are going to apply here. So if we apply this thing, then what we are going to get? That p is equal to e to the power t by 20 into e to the power c. Correct now? Now what is e to the power c? Is 1000. So from here what you can write, that p is equal to 1000 into e to the power t by 20. So this is a particular solution. Now what is our question? That in how many years that 1000 will double itself? The principal 1000 become, the new principal become 2000. At what time? So let us assume that at time t, p become double. That means 1000 become 2000. So from here what we can write, let at lowercase t is equal to uppercase t, that principal become double, that means 2000. So what will happen from here then? This implies 2000 is equal to 1000 into e power capital T by 20. Correct or not? So from here what we get, dear students? E power capital T by 20 is equal to 2000 by 1000. So from here what we get, capital T is equal to 20, or let me write one step and then explain. Okay, so from here what we can write, this implies capital T by 20 is equal to log 2 base E. Correct? So from here what we get? We get capital T is equal to 20 into log 2 base E. So that means what, dear students? In this many years, that is 20 log 2 to the base E years, okay, that money, the principal amount rupees 1000 will become rupees 2000. Okay. So with this note, let me conclude the class here. Your task is to log into the online test platform at konarclasses.com and appear for DPP, that is daily practice problem, followed by PT, that is practice test, followed by UT, that is unit test, followed by MDT, that is module test, and finally mock test. In this series of tests, if you appear, your preparation is going to be rock solid. Thank you very much. Bye bye.